Okay, so the title of the talk a bit too grandiose. What I'm actually going to talk about is about the critical gaps in the knowledge about critical minerals, critical metals, particularly in common deposits of traditional commodities. So however surprising it might be, there is precious little high quality, consistent, comprehensive public information about what those critical metal contents are in normal commodities and which of them can be economically extracted. And because of this key gap in knowledge, that's why GSQ is focusing a fair bit of our efforts on trying to characterize or geochemistry to characterize the content of critical metals as potential core and byproducts in normal deposits. And that's pretty much what the basics of this presentation is all about. So first, it would be useful to have a closer look at what critical metals are, because we haven't discussed them. And it's also always useful to put it in the context, because there are different definitions, there are different understandings, and some minerals which are vitally important and strategically important for the country don't make it to the critical list. And it's very useful to review why. For critical minerals in Queensland, mostly it's going to be reiterating the fact that our understanding of potential of existing deposits for critical minerals is poorly understood, and we need much more data. And that's what GSQ is doing has been doing for the past couple of years, and that's where we're going to focus our activities for the next 4 years. So critical minerals and what they are. However surprising it might be, but it's all over the news and everybody's talking about them for the past 5-7 years. There was certainly a flurry of activities and interest over the past year in Australia and overseas. But the concept is actually not new at all. So in fact, I think we should have celebrated somewhere close to a centenary of the precursor of the concept of critical and strategic minerals. Like, I was quite curious to find an obscure legal document with the title something like Strategic and Critical Materials Stockpiling Act 1939, United States of America. So if there was an act of Congress in 1939, the concept is much earlier, naturally. And what makes critical minerals critical? It's the strategic critical importance to the industry of this particular country. And the earliest definitions were rotated around the interest of the defense. But in recent years, it's more and more about high-tech industries, green energy. And because the focus is on national criticality, importance to national industry, there are different competing definitions. So what is considered critical for one nation can be not so critical to another. And what makes some strategically important commodities critical is serious major supply risks. So for example, something like copper and iron you can't do without, but because the global supplies are well distributed, the risks of serious disruption to supplies are not that great. As opposed to critical minerals which are focused on the production of which are focused in just 1 or 2 foreign countries, where there are political risks, political unrest, or just political interactions between different countries. And that was the source of the most recent interest in critical minerals dating back to 2013, when the world suddenly realized that just because you don't need too much of rare earths, and the relative value of global production and consumption is not that large, but you shouldn't consider it, take it for given that you're always going to get your supply as soon as you need it. So the definition is largely non-geological, but critical minerals have several common geological characteristics. So they have a tendency to be geologically dispersed. So either they don't form deposits in their own rights, or if they form individual deposits, they have a tendency to be geologically rare. They're characterized by low global production volumes, like quite often orders of magnitude lower than production volumes of common bulk commodities or common metals. So we're not talking about supplies of millions or tens of millions of tons. It's more like thousands or even tens of tons per year. And because of the geological characteristics and because of the low global production volumes and costs, revenues to the mining industry, they have a tendency to be highly geographically concentrated, and quite often, like rare earths, like cobalt, a single country accounts for more than 50%, sometimes 80, 90% of global supply. So the risks of global supply over medium to long term is really high. So in Australia, we have a relatively recent definition dating back to only last year. It's a group of 24 elements and they're well-recognized common groups, like the group in red is PGEs, platinum group elements. The blues are rare earth elements. Some of these commodities are nothing particularly groundbreaking. It's not that nobody knows about titanium or vanadium or chromium or tungsten. Some of them are actually very old commodities to the extent that they're kind of forgotten in Australia. Like we used to be a globally significant supplier of antimony and tungsten. Queensland at some point was the global dominant source of tungsten, and we're trying to revive that. Some others, most of us never encountered in professional life, like gallium, germanium, indium. Yes, we know that they exist, but who can think about a dedicated gallium mineral? I've never seen one in my life. And it is this second group of obscure minor commodities. They're particularly poorly understood. And a point of just mild curiosity, there is one light element here shown as critical, carbon, and it's not the shiniest and the most spectacular form of carbon people know. It's not about diamonds. Diamonds, however attractive they are, they're not considered nationally critical for Australia. It's just black graphite. So sorry to the best friends of diamonds. Graphite rules for critical minerals. Australia is quite well endowed in critical minerals. Queensland in particular, we have most of them. We have quite significant supply of some of them. And so basically they can be subdivided into two big groups, the ones which do form deposits in their own right, like tungsten, or are extracted as common core byproducts like cobalt, or deposits like lithium, rare earths, and vanadium. And so the highlights, the bold here indicates commodities which we consider particularly relevant, particularly important in Queensland. And the second group, which are almost universally, almost entirely extracted as byproducts, like gallium, germanium, indium, rhenium, for example. And understanding of prospectivity of those potential byproducts is particularly poor, and it's not just a problem for Queensland or for Australia. It's a big global issue. Quite often we are dealing in public domain with anecdotal evidence. So it's largely anecdotal evidence about the contents of gallium, germanium, indium in copper and lead zinc ores. Because it's not largely the matter of mining industry. Largely that's part of the refinery business. And I was curious to find out that, for example, one of the global leaders of supply of germanium is the great mining nation of Belgium. Who knows about any deposits in Belgium? I don't know. But they are smart enough to buy zinc concentrate, bring it to the country, and set up refinery facilities and extract them and sell it to the global market. So because these problems of understanding of even basic geological characteristics of common concentrations, there are so significant gaps, it has been realized by several governments. It has become the matter of serious intergovernment conversations. There were memoranda of understanding signed between different nations. There were high-flying activities of high intensity between the governments of Australia and the United States. And as an offshoot of that, a relatively recent international collaborative agreement is a Critical Minerals Mapping Initiative, which involves geological surveys of Australia, United States, and Canada. Its main focus is to address this key existing gaps of knowledge about critical minerals, to allow governments and their technical offshoots, geological surveys, to make some more intelligent assessment of critical mineral prospectivity. If you don't have the basic data, you don't have anything to talk about. And one of the serious bodies of work includes compilation and integration of existing data characterizing orogenic chemistry. So that's what 3 federal surveys are working tirelessly for the past several months. And they're focusing largely on bringing together existing information from historic samples in their possessions, including existing geochemical data, just to bring it all together. A separate body of work involves improving knowledge and understanding of critical mineral concentrations in different mineral deposit types and mineral systems, because it's not useful enough to say that, for example, germanium is concentrated in zinc ores, because not all of them are born the same. Some of them are indeed very seriously endowed and form the major source of supply. Some others are so poor that they're never going to produce any germanium unless you really become desperate. And it's very important for the geological community, particularly talking about critical minerals and less understood deposit types, is to get the terminology right, to make sure that geologists, at least of English-speaking countries, for when they're using certain names to describe certain deposits, it's good that they mean the same things. So there is a separate body of work to review the deposit type classifications. So that's a serious body of work on the way. Just pretty much bring it all together, linking it to existing definitions of deposit types, so that at least we have the shared vocabulary, so that we don't have to describe deposits in great detail. We can use deposit type name and people would understand what we mean. And I wanted to talk more about that, but that's a separate topic. That's for later. This work is underway, and you're going to see some results of that probably in the next 6 months or so. So the most significant focus of our activities is on this part of compilation and integration of geochemical data. And in GSQ, we're focusing not so much on compilation of existing data, because quite often it's just lacking. So we're going out and do the actual data acquisition, going back to getting geologically constrained samples representative of key deposit types and key deposits, and doing consistent geochemical characterization for the full range of commodities. So that's pretty much the first time we're undertaking these efforts, and that's why I will take you through the reasons why we're doing it and the nature of work, and I will give you some teasers of some preliminary results where our results are a bit more progressed. So first of all, when we looked around for the existing data, and that data we could compile, that was a clear realization that quite often is just simply missing. So quite often there's critical minerals which are of a particular significance, and we know that Queensland is a major supplier of several of them, which are getting extracted elsewhere overseas. The data is simply not there because companies rarely assay for these obscure metals. So we need to go out and collect this information. Relationships of critical minerals and commodities of traditional types. That's a very interesting topic because critical metals are not always sitting together with the main commodity. Sometimes they do, but mostly they do their own thing. So sometimes it's enrichment of certain parts of deposits, or sometimes it's products of the same mineral system, but forming concentrations spatially distinct from main commodities. A few other things which we're addressing through other bodies of work include factors controlling critical metal abundance and distribution. So why they're concentrated in some places. Is it good enough to have phosphorite? We need to have something else to get good rare earths. Same as, is it just enough to have an ICG to say that it's going to be enriched with rare earths? Or there is something else? Very important to know further down the track is modes of occurrence of critical metals. So whether they form their own minerals or they're consistently sitting as parts of some other minerals. and their progenetic relationships, because it has major implications for metallurgy, which is the next key issue, metallurgical methods for potential extraction. Because quite often, with lots of critical metals extracted exclusively as byproducts, the issue is not geological availability, they're present. It's not even so much of geological concentration. We're getting more and more information about their relative enrichments in places, but how to extract them. And that's a separate body of work, particularly the work of UQ-BRC. So for the rest of the talk, I'm going to talk about just the first point about abundance of critical metals in key deposit types, in key ores. So the particular geographic focus is on North Queensland. That's the area particularly strongly endowed in a large collection of different critical minerals and traditional commodities. So the focus is very firmly on collecting consistent geochemical information on critical minerals, going back to the basics, to the primary geological samples, and understanding their context. So it's no use just collect a bunch of rocks and throw them in the machines without understanding the context. And this focus area is precisely the focus area of the new Economy Minerals Initiative held introduced at the beginning. So that's where our focus is going to stay firmly for the next 4 years. And because the area is still immense, the scope of work is huge, we just stage it by geographic area and by deposit type, because the scope is large, our team is small. So we generally started moving from the west. That was pre-existing the current most progressed body of work on Northwest Queensland, where we have a series of world-class deposits of copper, lead, zinc, silver, of different deposit types. And that's where most of our discussion today is going to lie. There is a very interesting suite of extremely diverse deposits in Northeast Queensland, tungsten deposits, chrysins, veins, intrusion-related gold, in a broad definition as a mineral system name rather than deposit type name. They have affiliated deposits, skarns and veins, which are much richer in critical minerals than gold deposits proper. Polymetallic veins, they're probably the most spectacular ones and the least understood. The most spectacular because they have absolutely ridiculous grades of base metals, silver and indium. So indium goes into tens to hundreds of ppm, which is many orders of magnitude above the crustal abundance, and they're poorly understood because they're veins, and in the past 50 years, not many people cared about them. And then there are bauxites, and that's a premium source of gallium globally. We have done some work initially. We know enough to be excited to follow up, but I'm not going to talk more about them because for now we just have solid data from a single deposit, and yeah, probably it's premature to talk about that now. So let's talk about work in Northwest. So this work was commenced under a new discovery program. We kicked it in back in 2018, and it started as an offshoot of a pre-existing project which was funded by JSQ many years ago. Work by CSRO, who did some sampling of different deposits around Clascaran district, releasing results in 2015. And we renewed this work in 2018, and we used lots of historic samples, and that was the beginning of this particular body of work. So the focus initially was on ICGs, copper, gold, and affiliated deposits in Eastern Succession, and we're gradually progressing to the west to, in broad sense, what can be described as sediment-hosted copper of different types, and zinc-lead silver systems, and most recently phosphorites. And in this area, same as everywhere we're progressing this work, it all starts from acquisition of representative core, continuous spectral scanning, high logger, XRF scanning. It is commencing in early 21. Mineralized instrument is going to be hosted in our core store in Brisbane. and operate for at least 6 months. And we're going into more and more into microanalytical techniques. I'll say a few words a bit later. So for now, just in this region, just for these deposit types, we have more than 2,000 new geochemical results to date. So I'll just give some breakdown by deposit types and giving some teasers I was talking about. So first, phosphorites, focusing on Cambrian phosphorites at the base of Georgina Basin. So this project was conceptualized in broad terms in late 2019, but kicked off in real earnest with the arrival of Matt Valentich. So he's going to tell you much more about that 2 talks from now. So the big focus was geochemical characterization of key deposits and occurrences all over the region, and the map shows the spatial distribution. So pretty much we have most of the significant deposits and occurrences and most of the region covered. It's more than 700 geochemical results to date characterizing rare earths. Teaser results indicating that at least some parts of these phosphorite deposits are really significantly enriched in rare earths compared to their global peers, including the ones which are dominating global supplies of rare earths. And particularly pleasing and useful to know that the best samples from Georgina Basin shown here in blue, they're significantly enriched in heavy rare earths, which are much more expensive and in much shorter supply. So Matt will tell you much more about that in detail. Base metal deposits, I will speak much more about ICGs, a little bit less about copper and lead zinc, just because we have started from the east. From sediment-hosted copper in broad terms, we're not so progressed, but I'll take you through them as well. And lead zinc, it's also work in progress. So ICGs, we have most of the key deposits covered. There are a few glaring emissions because we couldn't get our hands on good samples. So we collected about 1,000 new geochemical results from ore to distal portions, about 200 of ore samples. So the key point of this obscure slide is that there is overall signature, which is common for most deposits. And there are also geochemical variants, some of which are enriched in things like light rare earths and tungsten, moly, and a few other metals. And the important consideration here is that because of the great geochemical variety of ICG deposits, they're not born equal in terms of their critical metal potential. Some of them are very interesting, some of them are less so, and the list of deposits and commodities different. So a different take on that, highlighting in a bit more visual manner that there are indeed 3, perhaps 4 distinct geochemical varieties of ICG deposits. These 4 geochemical classes highlighted by different color, and symbols indicate individual ore samples from individual deposits. So here, a particular significance to note, for example, this group of symbols which indicate samples from Swan. They indicate that a particular trend of light rare earth enrichment, and this is the deposits where we found by far the highest common rare earth grades. And I'm not going to talk more about that. I'll leave it to Ross Chandler to say more, who is doing more work on rare earths and ICGs. And another point of curiosity, a much less common class shown here in blue. Caltha is probably the best known example of those, characterized by preferential enrichment in heavy rares. Not spectacular, but it's certainly interesting. So a very quick but messy way to illustrate relative critical metal enrichment. It's a horrible complex diagram. Each line represents a ore grade sample of 0.5% copper or more. And critical metals shown here are just the metals which are consistently enriched in most deposits. So a bit of an exception from that is rhenium, which does occur in spectacular quantities, but only in some moly-rich examples of deposits affiliated with ICGs. Cobalt is quite common but not universal, and there are interesting indications of like really serious concentrations of indium, which are getting to the points comparable to the grades commonly extracted globally. So just to summarize it, cobalt is pretty much universal. Cobalt grades in bulk of the order of 500 ppm, it's pretty common. Like bulk deposit grades, there are some smaller deposits which are getting a fair bit richer than that, towards 0.1, 0.2%, and some parts of some deposits are getting towards there, and individual samples can go much higher than that. But 0.1, 0.2, it's certainly interesting. It's getting towards the realm of relatively poor magmatic copper, nickel, cobalt ores from which cobalt is actually recovered. So rhenium is very, very interesting in places like Merlin and Kalman. And Merlin is the only deposit known to me which could make it as a rhenium deposit in its own right, even if you forget about molybdenum. So it's certainly interesting to know. And rare earths, it's, well, unlike what you may have heard if you're not working with ICGs, that ICGs are always enriched in rare earths, not always, only sometimes, and only in places it's getting to the stage of being really interesting. Zinc, lead, silver deposits. This work we started in earnest only this year. So we have acquired good samples from a bunch of really representative deposits. We have done some geochemistry on some of them. We're going to go more into continuous XRF scanning coming early next year. We're going, in addition to characterizing primary deposits, we're also going into characterizing tailings with University of Queensland, and going further into detailed deposit characterization studies with CSIRO codes and our own work. And here we do have serious gaps in knowledge and geochemistry, and here there is plenty of scope for us to get some more sample acquisition from other deposits other than those listed here. So it's more contributions are still welcome. And why it matters, just to reiterate yet again, germanium in particular, this has been focused of work of Geoscience Australia, Dave Houston and the team, which they did a review around the country. So what is the germanium endowment of different deposit types, and what is the potential endowment of zinc, lead, silver deposits of different kind around the continent? And as you can see here, deposits around Mount Anza, they clearly stand out as a potential source of major germanium endowment in the country and certainly globally. And we're doing more work to characterize geochemistry of them. And as I mentioned, we do need more samples from more Queensland deposits. Copper deposits in Western Mount Isa, same as lead, zinc, silver. We started serious work just now. We've got good samples from Mount Isa, courtesy Glencore. We have some good samples from Capricorn Copper, Lady Annie, some, but not ideal, but some samples from Wolford Creek. So here it's certainly a call out for more contributions, more samples. Right now we're in a position to do more work in this regard. And with the advent of New Economy Minerals Initiative, we are returning our focus on Northeast Queensland as well. There is a high potential for the whole series of critical minerals, and for example, tungsten is particularly spectacular. There are some deposits which would make which can compare very favorably to good examples of global deposits of tungsten. Same story, we start from acquisition of representative core, and at this stage we are in the midst of major campaign of core acquisition. So it's pretty much right now. Courtney Dinaram is very busily and tirelessly trying to follow up with a bunch of companies to get hold of good core. Future work, we have done a fair bit. We have done a good impression on ICG deposits, but some other deposit types and some other regions are much poorer characterized. So we'll continue our deposit characterization work in close collaboration with our partners. Prospectivity of mine waste, that's a particular body of work which is a particularly significant focus for us with BRC UQ. That's certainly going to continue and expand for the next 4 years. G-Science Australia, we're certainly planning to extend much more significantly our collaboration with them under the Exploring for the Future extension program on regional and national scale projects. I was hoping to be able to say a bit more about that, but we'll have to wait until they make official decisions and announcements about the project breakdown. They're going to proceed. It's just a couple of weeks away. And key outputs of the critical minerals mapping initiative is going to come out in a matter of months rather than years, including that the first step at the International Geochemical Database of OG chemistry. So it's going to be a very, very significant resource for everybody interested in OG chemistry in general and critical minerals in particular. And at this, if you remember just one point of what I said, I hope it should be something like GSQ is doing a lot of work trying to do characterization of deposits of Queensland for critical minerals. We are very keen to get hold of more representative samples and do more work on them. And if you have any remote interest, just out of curiosity or out of altruistic care for greater good or for personal reasons because you want somebody to do your work for you for free, please talk to us. We're in a position to do that work for you. Thank you.